Hi everyone. So in today's video we will study how to really interface a sensor with Arduino and code. So the sensor we are going to use is called LM35. So English letter L M35. So it is an analog based temperature sensor. Okay, so there is a way to connect the sensor and read its analog values and convert it to a readable temperature values, because analog values are coming somewhere between 0 to 1023 units. So we have to convert it to temperature values again. Okay, so the temperature value will be converted into voltage by the sensor and it will give you the values. So Arduino will take it as 0 to 1023 analog values. So we have to again convert it into voltage value and temperature value, or directly to temperature value. So to start that, you want to see something basics. Okay, so look at this area. So I am like on the top of that there's Arduino and a 5 voltage and 0 voltage, things like that. So this is something you studied earlier in your analog input parts. What you do is you take the voltage output from a source, maybe a variable resistor or a sensor or anything. So then that voltage output is converted into brought into 1024 units that start from 0 and end in 1023. So then 1024 units means 5 voltage. Okay, so if the 5 voltage is coming, we will have 23 as the highest number. So according to the voltage the sensor gives, we will have the particular number as displayed. Okay, that is the concept of analog inputs. So 1024 units for all the 5 voltage. So we will know 1024 units for the 5 voltage. So we will know the value of the 1 unit. Okay, or the value 1. 1 unit value. Okay, so that is 5 over 1024 voltage. So let's say a sensor is giving you a voltage, or you are getting a voltage value to the particular pin from a source. Okay, like this, and you don't know the exact voltage value. So now you have that equation, right? So the voltage value for 1 unit and you are getting the unit value from the Arduino, right? Anyway, you are not reading the voltage value directly. Analog will give you the unit value between 1024 units. So you know the 1 unit value now, right? 5 by 1024, because we know it from our theory. So then if you multiply that value by 5 over by this 5 over 1024, then you will get the voltage value, right? Obviously, because 1024 units means 5 voltage. So 1 unit means 5 over 1024 voltage. So if you know the units, and then what you have to do is you have to multiply the 5 over 1024 with the units that you have. So then you will get the particular voltage. Let's say you are getting 1024 units. That means the value is 1023. So that means 1024 units. Then if you multiply by 1024, you will get 5 voltage, because 5 over 1024 into 1024. That means 1023 value will be giving 5 voltage. Obviously, right? If you are getting 5 voltage, the value will be 1023. So these things I already told you in the previous sessions, one of the earlier sessions. So you can go and watch it again. So let's say X is the value you are getting by reading the analog read A0, right, from the source. So X is the unit value, right? So what you have to do is first you have to add 1 with the X to get the voltage value. You have to add X plus 1. Okay, X, if you get X, you have to make it X plus 1, because we start from 0. I already said you that 1023 means 1024 units, like that. So you have to add X plus 1 and you multiply it by the 5 over 1024. So then you will get the voltage value of the source. There's no doubt on that. So Arduino can be used as a voltage meter. What you can do is you can connect to the analog, connect the input value to analog pin. You read the value, then you increase the value by 1, so that you know the unit numbers, and you multiply it by 5 over 1024. It will give you the voltage value that is coming to the particular pin. So Arduino can work as a voltmeter, somewhere between 0 to 5 voltage. So like that, if you connect the temperature sensor, you here also, since it is an analog sensor, it will give you the values from 0 to 1023. That means 1024 units. So to convert that value, that means 0 to 1023, any value you are getting, to convert the value, there may be an equation, right? Like to convert the value into voltage, we have the equation that X plus 1 into 5 over 1024. Like that, to convert that value into the real temperature value that is coming from the temperature sensor, we can have equation, right? There may be an equation, someone might have derived an equation. So if we apply the equation and get the results, then we will get the temperature value, obviously. So that means here what happens, we get the voltage value, Arduino automatically converted it into 1025 units, and we have to again convert it to make it a voltage value and read it. Like that, temperature sensor is also making it into a voltage value and giving you the input value. Arduino will take it as a numbers from 0 to 1023. Again, we can use another way to we can reconvert it to temperature value so that we can read it, because Arduino will only take it as a analog number values, but we want to see it as a temperature value. You understand? So that value you can even add +1 and multiply by 5 over 1024. You will get the voltage value that is coming from the sensor. But that is not our task. We want to know the temperature value. So there may be another equation to find it out. So before that, we will come to the connection of the sensor. So this is LM35 sensor. So if you keep the sensor this way as in the picture, so then you can start from left side. So 1 2 3, pin number 1 2 3. Okay, so you have to keep it this way. If you keep it the other way around, this will be messed up. So you have to keep it this way, pin number 1 2 3. So pin number 1 should go to +5, and pin number 3 should goes to ground, and pin number 2 should go to the analog pin. This is the rule of connecting the LM35 temperature sensor. Okay, so now you have the idea of the connection. If I give you the sensor, you can connect now. So pin number 2 should go to the analog pins A0. So that is our concept. Okay, so now what we'll do is we know A0 is getting the input. So pin number 2 of the sensor is going to A0. Okay, so according to Arduino, A0 is the input pin. So we will read the analog value here as mentioned here. We'll read the analog value, and let's say we are assigning to a variable called X, like how we assigned it earlier. Okay, so X. So now to calculate the temperature value from X, okay, if you want to calculate the voltage value from the X, that means you want to calculate the voltage that is coming from the sensor. What you have to do, you have to multiply it by 5, or you have to increase X by 1, and you have to multiply it by 5 over 1024. Then you will get the voltage value. But when it comes to the temperature sensor, we don't care about the voltage value. We want to know the temperature value. So there is another equation to find out the temperature value. What you have to do is, you have to get the analog read value first, X value, and you have to multiply the X value by 0.48828125. So this is a derived rule. So you may study how this value has obtained, and that is another thing. But just remember, this is the direct rule. In future, this value may change. There may be some differences, but we don't care about that. We just want to know the logic of this working scenario. So you can go for your own reading as well. So just for the moment, we will take it this way. Okay, so you have to multiply X by that analog read value by 0.48828125. That will give you the temperature value. Okay, so that's all. So we will get into the game and we will start code, right? Okay, then I'll open my Arduino. Oh my god. Okay, I will retype this void. I have already typed it, but it has gone since it's minimized. So give me a minute. I will retype the void setup and void loop. Void loop. Understood. Okay, so that's all. So now what I will do is, I will connect the, let's say I have connected the sensor to A0. Okay, so what I have to use, I have to say pin mode A0 is input. Okay, so since we are using an analog input, we don't have to talk about pull up, pull down, things like that, right? Because it's analog input. So you have to say pin mode A0. When it comes to digital input, then we may have to mention it as a input pull up if we need it as a input pull up switching, or even we can mention as a input and we can create the external circuit. So that is another thing. So when it comes to analog inputs, we have to mention it A0 and an input. So if you have any question, you can go and watch my analog read analog input parts of the series, okay, of this video series. So this thing is fine. That's all we have to do. And also we have to start the serial communication. So I will write it on top. Serial could begin 9600. Okay, that's beautiful. Okay, so now I will read that temperature value first and assign it to X. Okay, series X is equal to analog read what's the value? A0. Okay, that's fine because we already said A0 is an input. Okay, so this is fine. You know these things, how to read the analog value. Now we know the value, right? How to convert it to temperature. Now we have the x value as 0 to 1023. It can be any value because there is an analog read value. To convert it to a temperature, what we can do? We have to multiply the x by, as we saw now, x by 0.488 28125. So this will give you a number value. So we will assign this value to another variable called T. So that means temperature, let's say. So T. Okay, that's beautiful. And I will because now we have the temperature value as T. Now what I will do is I will serial print the T values. Okay, serial print ln T. So you know how to print the variable in the serial print ln, just passing it is enough. Okay, so that's all we have to do. And there's an important thing we missed, but is that, so we are assigning the value to x and t, but we didn't declare the values. Okay, we have to declare them. So I will declare it as a global variable. So this is inside the void loop. So if I declare it inside the void loop, that's enough. But still, according to the habit, that's a kind of good habit. Where's that? Okay, good habit. So I'm willing to declare it on top as a global variable. So in case I won't use it, if I may write another method, let's say I won't use it in some other methods I can use. Okay, so just don't worry. I'm just saying, okay, int x. So that's fine, integer x, because the values are coming from analog read are 0 to 1023. So integer values. So I say int t and I declare t as an integer. There's a problem. Can you tell what it is? The problem is when I am saying integer values, you cannot have the point values. That means decimal values. Decimal in the sense 0.25. The values that is coming after point. Okay. You cannot have integer values are full numbers, right? How to say full numbers like 1, 2, 3, 4, 5. 1.5 cannot be there. You understand? So if I say t as an integer, so let's say if I am multiplying the x value, maybe x can be 1 or 2 or 3 or 5 or maybe 1000. If I multiply the value with the 0.4882825, will I get a full number, integer number? No, it will be a decimal number, right? In most cases. Okay, it will be a point number, decimal, not decimal. It's a, I don't know what the decimal means. It's a point numbers, right? Pointing values. That means if the x value is 1, then output will be same as 0.4882825. Is that an integer number? No, it's a point number, right? It's coming after a point. 1 point something, 2.1.5, 2.5 like that. If this is a 2, then it can be the double x. If x value is 2, then t value will be like double of that, right? 0.96 or 7 or something, right? 97 or something, 97 blah blah blah. So this is also a point value. So if I am saying t as an integer value here, t cannot hold the point values, because logically talking, the temperature cannot be a integer value always. It can be 4.25 degrees Celsius, it can be 30.27 degrees Celsius, it can be 25 let's say 69 degrees Celsius. So those are point values. It doesn't be the full now 25 degrees Celsius always. It cannot be the 27 degrees Celsius always. It can be 27.12, 27.03 like that. So point numbers. So integer data types cannot hold point numbers. I told it already, right? So integer cannot have 1. Integer can have 1, but integer cannot have 1.5. There cannot have any 1 point values. I hope you understand what I'm talking about. Earlier videos also I talked about this thing. Okay. So that's fine. So what I have to do is I have to change the data type of the integer. So I already told you to hold the point values, we have two data type, float and double. Okay. So float has some kind of accuracy, I think 7 or something. That means 0.56. To some extent you can write numbers. I think up to 7 numbers. 0 point or like maybe to 100 point, anything. 134 point, anything, right? So point, it can hold point numbers. It has a range, but it can hold point numbers. Double means it is more accuracy. It is a double time accuracy of float. That means you can have more point numbers, more than float, right? Something like that. So that is double. So we will go with the float data types. So if you want, you can Google the float data types and double, and then you can get some idea. But for the moment, just remember to hold point values, point numbers. That means not non-integer numbers integer and non-integer numbers, you can use float. Okay, so 25.34. Integer cannot hold it. Integer can hold only 25, but float can hold it. Float can hold 25.34. So I will change it as a float data type so that the t can hold the returning value of this equation. Okay, so now the temperature can be obtained in with more accuracy with float point numbers. Okay, understood? So that's all you have to do. So now everything is fine. So you have to know these things, float kind of things, and you read the value, and the most important part is you should know this equation value. So if you want to display the voltage value or voltage value, then what you can do is you can let's say another float v. So since I am using v here, I can use it here, or if I want I can use outside also. Another float value v, and you can assign it to x into x plus 1 into 5 over 1024. You understand what I am talking about? Into 5. My god, what's happening here? What I am doing, man? Oh my god. Okay, into 5 by 1024. It will give you the voltage value, but we don't care about the voltage value. So in that case also we have to mention as vs float, because this also in most cases will give us point values. Okay, so we don't care about that, but we want to know only the I deleted, I'm sorry, only the temperature value. So that is the equation for this. Okay, so now you know how to read a temperature value for using analog read, and the new thing you studied is this line number 10, converting x into temperature values. Okay, so that's all for the session. We will study further with this in the upcoming videos. So now you can connect a temperature value, and you can read you can connect an LM35 temperature sensor. So I will type the name of the sensor as well here. That's it, man. Okay, that's cool. LM35. So this is the temperature sensor name, and you can Google and have a look at the code and understand what actually happens. So this is the same thing happens. You connect the sensor the way I said you, and you upload the code, and you will see the temperature values. So simply you have made a temperature sensor, temperature monitoring system in your house that can be seen in your computer display. Now you can give outputs according to the temperature values. You know how to handle if condition, so you can do those things. So those things we will see in the upcoming videos. So I hope you understood what I am teaching. Otherwise, rewatch the video and you can ask me a question, I will answer you. So I will catch you up in the next video. Until then, consider subscribing us and have a great day ahead. Bye.